Good day, everyone. So this video presents the discussions on the properties of circles and the remaining parts, remaining topics for solid plane geometry, which is about similar figures. Okay. So property number 1 for circle. A radius drawn from the center to the point of tangency is perpendicular to the tangent. So let's say, if you have a circle here and then you draw a tangent, so this is what we call the black line, is what we call the tangent, and it intersects the circle at one point only, and we call that the point of tangency. So if we draw a line from the center to the point of tangency, then that is a radius, and that line or the radius is perpendicular to the tangent. Okay, so to illustrate, we have problem number 1. A circle is tangent to two perpendicular lines. A smaller circle is drawn inside such that it is tangent to the lines and the bigger circle. What is the area of the smaller circle if the big circle has an area of 50.4 square centimeters? Okay, so we have a circle, the given circle, tangent to two perpendicular lines. And then there is a smaller circle which is drawn such that it is tangent to the two lines and also to the given circle. So the bigger circle is the given circle. So what is the area of the smaller circle if the bigger circle has an area of 50.4 square centimeters? Okay, so we are given the area of the big circle, so 50.4 square centimeters. I can solve for the radius of the big circle. So using this area equal to 50.4 equal to pi r squared. So the radius of the big circle, which is big R, equal to 4 cm. So we can draw the figure. So we have a circle, and then you have the two perpendicular lines tangent to the circle. So we have that now. Then we can draw a small circle here, which is tangent to the two perpendicular lines and to the given circle. So question, find the area of the small circle. Okay, so to solve for the area of the small circle, of course, we need to compute its radius. Okay. So circle, tangent, so if we connect a point from the center to the point of tangency, this is the radius r. Big R for the big circle. Also here, this is R. Okay, we have computed this earlier in the previous slide. This is 4 cm. Okay, then this small circle is also tangent to the given line. So from the center to the point of tangency, this is radius R, small r. Small r for the radius of the small circle. Also here, so we have this R also. Okay, so this is big R and this is small r. So we can compute for the length here, and this is R minus R. Also here, this is R and this is small r. So I have here also R minus R. Then from the point of tangency of the two circles to the center of the small, that is also R. And from the point of from the center of the big circle to the point of tangency, this is also radius of the big circle r. Okay, so the length from center to center of the two circles is r plus r. So have you noticed? We have formed here a right triangle with the two legs measuring r minus r and the hypotenuse r plus r. So we can use the Pythagorean Theorem. Okay, then substitute the value of the big R, which is 4. And from this equation, we can solve for the radius of the small circle, equal to 0.686. So for the question, the area, that is pi r squared. So 1.478. Okay, so that is property number 1. So if you have a circle and then you have a tangent drawn, so if you connect a line from the center to the point of tangency, then that is perpendicular to the tangent. Next property, by the way, before discussing the next property, we must first define what is or how we measure an arc of a circle. So we have here the measure of an arc can be expressed in terms of the central angle of the arc. So let's say if we have an arc, so if we have an arc, for example, this arc of a circle, so if we have this arc, then no matter what the measure of the radius, or if in case we do not know the radius of the circle, then the measure of the arc can be expressed in terms of the angle at the center, subtended by the arc at the center of the circle. So meaning, we can express the length of the arc not only in terms of the length, in terms of linear unit, but we can express the measure of the arc in terms of the angular unit, and that is the angle subtended by the arc at the center of the circle. Okay. So for example, if we have here a 30-degree arc, so a 30-degree arc means we have an arc of a circle in which the angle subtended at the center is equal to 30 degrees. Okay, so let's say if we have a 90-degree arc, so that is 1/4 of a circle. So we have here a 90-degree arc. Okay, so we have now property number 2. The angle between a tangent and a chord or secant is equal to 1/2 the measure of the intercepted arc. Okay, so the angle between a tangent and a chord, or it can be a secant, is equal to 1/2 of the measure of the intercepted arc. So we have here, so if we have a circle and then we draw a tangent, then we draw also a chord. So a chord, or it can be a tangent, or a secant, we know a secant is a line drawn which intersect the circle to 2 points. So if we have a chord, if you extend the chord on both sides, then it becomes a secant. So this is why this is chord or secant. Okay, so the angle formed between the tangent and the secant or the chord is equal to 1/2 of the intercepted arc. Now notice that the intercepted arc between the tangent and the chord is this. This arc here, from this point up to this point. And the measure of this arc is, or can be expressed in terms of the angle at the center. So the angle or the measure of this red arc, intercepted arc between tangent and the chord is equal to the measure of the angle here. And if this is angle theta, then the measure of the angle between tangent and the chord is beta, and beta is equal to theta over 2. Okay, so that is property number 2. Number 3, inscribed angle in a circle is equal to 1/2 of its intercepted arc. So what is an inscribed angle of a circle? So if we have a circle and then we draw an angle inside such that the vertex of that angle is at the center, or the vertex of that angle lie on the circumference of the circle, then we call it an inscribed angle. So the blue angle here is an inscribed angle of the circle, and the measure of that angle is this. Now, take note that this is the intercepted arc of the inscribed angle from this point up to this point. So from this point up to this point. And the measure of that arc is equal to the angle at the center. So if this arc measures angle theta, then the angle, the measure of the inscribed angle, beta, So beta is equal to theta over 2. Okay? So inscribed angle is equal to 1/2 of the intercepted arc. Okay. Note, we have here, inscribed angles with the same intercepted arc are equal. Huh? So in a circle, if you draw many inscribed angles, wherein the inscribed angles has the same intercepted arc, then the measure of the inscribed angles are equal. For example, I have this inscribed angle. Huh? So the intercepted arc is here. Huh? And this measures beta. So if I will draw another angle in which we have the same intercepted arc as the blue angle, then the measure of that is also beta. Okay, so observe here, no? So the measure of this green angle is also beta, because we have the same intercepted arc. We can draw another inscribed angle with the same intercepted arc, and the measure of that red angle is also beta. So that is so that is coming from property number 2. 3 now. So property number 4, any angle inscribed in a circle is a right angle. So any angle inscribed in a semicircle is a right angle. So we have here. So if this is a circle, and then we will draw an inscribed angle, and the intercepted arc is a semicircle. So that is why any angle inscribed in a semicircle. So of course, this is 90 degrees. Why? Because the intercepted arc here is a semicircle which measures 180 degrees. So this angle here is 90. We can draw another inscribed angle of a semicircle. So this is a right angle here. We can draw another inscribed angle of a semicircle. So this is a right angle here. Okay? Problem number 2, we have here, a quadrilateral ABCD is inscribed in a given circle. So a quadrilateral ABCD is inscribed in a circle. So meaning, this quadrilateral ABCD is cyclic na. Okay. The angle ADC is 75 degrees and the angle ACD is 45 degrees. If the arc BC is only 1/2 of arc CD, find the value of angle BCA. Okay, so again, we will draw the figure now. So we will plot the points. So I have here first the circle, and then I will place quadrilateral ABCD. So ABCD. Okay, let us say this is the quadrilateral ABCD. Then what are the given? The angle ADC. ADC, so this angle is equal to 75 degrees. And the arc ACD is equal to 45. Arc ACD. Angle, the angle ACD. Angle ACD. So if I will connect the diagonal, if I will draw diagonal AC, so angle ACD is 45. So we have that angle. Okay. So the question is, find the value of angle BCA. BCA. This angle here. This angle here in which the arc BC is only 1/2 of arc CD. So again, we would like to recall that the measure of the arc is equal to the angle at the center of the circle. So meaning, the measure of this arc is equal to the angle at the center. Okay, so we have here. So I will call the unknown angle theta. So that is our aim. What is the value of that angle theta? Okay, so from triangle ACD, I can solve for this angle. Because this is a triangle, we have two known angles, so we can solve for the third angle. So I can solve it. So this is equal to so triangle ACD. So 75 plus 45 plus angle CAD equal to 180. So angle CAD, this angle is equal to 60 degrees. Okay, now, notice that the angle 60 here is an inscribed angle of the red circle. Can you follow? Wag mong tingnan to. Ito lang, no? So, this angle 60 is an inscribed angle of the circle. And the intercepted arc is from C up to D. And the measure of the arc CD is here, no? So, measure of arc CD is here. Now, notice that the measure of arc CD is twice of 60. What's the reason? Because inscribed angle is half of the intercepted arc. Or if we are given, or if we know the value of the inscribed angle, so the intercepted arc is twice of that. So the intercepted arc is 120 degrees. Okay, now arc BC is only one half of CD, and CD is 120. Note na? So meaning, the measure of arc BC is only 60. Huh? So arc BD, arc BD, arc BC. This is not BD, BC, no? Kindly correct, BC. So arc BC, kindly correct ha. I cannot erase it. Kayo na lang mag-erase. So arc BC is one half of arc CD. So this measures 60. And take note, if this BC, or considering this arc BC, we have an intercepted arc here. Huh? So an intercepted arc in which we have here an inscribed angle. So this inscribed angle measures one half of 60. So meaning this is angle 30. So BAC is equal to 30 degrees. Okay. So ano to? BCA. So this is angle 30. Okay? So if we consider the whole quadrilateral, which is ABCD, quadrilateral ABCD is cyclic. No, and cyclic quadrilateral, the sum of the opposite angles is equal to 180 degrees. So if we sum up angle BAD, which is this 30 plus 60, plus angle BCD, which is theta plus 45, and the sum there is 180. So substituting values, 60 plus 30 plus 45 plus theta equal to 180, and angle theta is equal to 45 degrees. Okay, so what property involves there? That is about measurement of the arc and also the inscribed angle. Okay. Problem number 3. The circle ABC, having a radius of 6 centimeters, passes through the center O of circle ABD, having a radius of 4 cm. If the angle ADB is equal to 50 degrees, find the angle ACB. Okay. So, again, may mga letters tayo dyan, no? A, B, C, D, O. Plot natin, ha? Okay, so, that is the first step, no? Read, understand the problem, plot, no? The given, draw the given so that you can analyze the problem. Okay. So, may circle ka. I don't know why it is named as ABC. And then we have also a circle named ABD. Of course, in the first circle, the AB is the same as the AD in the second circle. Okay. So, let us say I have here a circle. So, let us say, hey, this is A, this is B. And then D. Okay. Now, there is another, so the circle, the center of the circle is at O. Now, the circle ABC, sandali, okay. The circle ABC having a radius 6 passes through the center O of the circle ABD having a radius 4. So meaning, this is the smaller one. Then the bigger circle is to be drawn so that it will touch, or it will pass through point O, the center of the circle ABD. Like this, okay, so meaning that is why A and B are common points between the two circles. Okay, then we have here circle ABD, the blue, And circle ABC, the red. Okay. So, angle ADB. Huh? So, angle ADB. If angle ADB is 50, you can place it anywhere. Na? You can place it anywhere, somewhere here or anywhere. Na? Okay. So, find the angle ACB. You can place also C in any position, somewhere here or anywhere. Na? Okay. So, this is 50 and this is now the unknown. Angle ACB. How will you solve that? Okay. So, consider circle ABD. So, circle ABD, the blue circle, I can solve for the angle at the center. Theta. Angle, not represented here. Now, note that angle D here is an inscribed angle of the blue circle. And the intercepted arc is arc AB. And the measure of arc AD is this angle. So meaning, this is 100. Arc AD is equal to angle AOB. So this is 100. Reason? Because this angle is twice of the inscribed angle. Okay? Then how will we solve for the angle at C? Okay. I will consider circle ABC. And I will consider the quadrilateral AOBC. So, kita nyo yung quadrilateral AOBC. So, AOBC is a cyclic quadrilateral because that is inscribed in the red circle. So, again, the angle, the opposite angles of a cyclic quadrilateral, the sum is equal to 180. So, if we sum up, angle ACB plus 100 is equal to 180. So, if this is 100, this is 80 degrees. Okay? Also, the property of cyclic quadrilateral is applicable in solving these types of problems. Okay, number 4. A circle having a radius of 9 centimeters circumscribes a right triangle whose area is 43.23 square centimeters. If one of the sides is 18, another side is blank. Okay. So, we have 3 sides of a triangle. We are given one side. So, we lack 2. But the question here is, another side is blank. So, meaning, we are asked for one side only, the measure of one side. So, if my choices if there are choices, then we can determine, So, once we have an answer, we refer to the choices and we will discover if the given there is the shorter leg or the longer, okay, or the shorter side or the longer side, okay. So, we will draw a circle first. A circle having a radius of 9 circumscribes a right triangle whose area is 43.23. So, I have here a triangle and then we have an inscribed circle, or circumscribed circle. Now, notice that the circle has a radius of 9 and one of the side of the triangle is 18. So, ano bang makukuha natin dyan? The circle has a radius of 9 and the side of the triangle, the given side is 18. So meaning, twice the radius is the diameter. So the diameter of the circumscribed circle is also 18. So meaning, when we draw the triangle, this given side which is 18 coincides a diameter. So this is a diameter, and this measures equal to 18. And this is right angle here, because we know an angle inscribed in a semicircle is a right angle. Okay, so that is 90. Okay, so we do not know the 2 legs, so either of the 2 is given in the choices if there are choices in this problem, Okay, so let's say x and y are the 2 legs, So from the area is equal to 43.23. So from the area equal to 1/2 x times y. So 43.33 equal to 1/2 xy. So we have y expressed in terms of x. And then from Pythagorean Theorem, x squared plus y squared equal to 18 squared, second equation. Then I can substitute equation 1 to equation number 2. So substituting, so we have here, and then we can solve for x. Okay, now, take note that we have two values of x, 5 cm and 17.29 cm. And from that, if we substitute back to equation 1, equation 1 is y equal to 86.46x. This is equation 1, y expressed in terms of x. Okay, so if x is 5, so substitute 5 here, so this is 17.29. And if x is 17.29, substitute y is 5. So that means we have only one set of answers, 5 and 17.29. Can you follow? So the two legs or the two sides are 5 and 17.29. So if in case there are choices in this problem, may choices ka for the board exam problem. So either of the two is given. Either we have there in the choice 5 or we have 17.29. Okay? Number 5. A, B, and C are 3 points in a horizontal plane. So once you read every sentence, you picture out it. A, B, and C are 3 points in a horizontal plane. AB equal to 25 and PA is a vertical pole. The angle of elevation of P from B and C are 20 degrees and 30 degrees respectively. Okay, so the top of the pole is P, and then the angle of elevation of P from B and C are 20 and 30. So can we draw now the situation? Then AB and C lie in a circle with AB as the diameter. Find the area ABC. Okay. So we have here triangle ABC. So ABC is on the horizontal ground. So the 3 points A, B, and C lie on a horizontal ground. So we will draw the figure here 3D. Okay. Then we have here the vertical pole. So the vertical pole, the base is at A because PA is a vertical pole. So from B, the angle of elevation of P is 20 degrees. Then from C, the angle of elevation of P is 30 degrees. Then AB is equal to 25 meters. Now, AB and C lie on a circle with diameter AB. So can you imagine that? Okay. So I can solve for the height of the pole from triangle PAB. So this is right triangle here. Also at CAB or CAP. So CAP, this is also a right triangle. Okay. So triangle PAB, so we have the tangent of 20 equal to PA over 25 and PA is 9.10. Then consider triangle C or PAC. So tangent 30 is equal to PA, which is 9.10 over AC. So AC can be solved 15.76. Okay na. We consider the triangle. Now the triangle the triangle or the 3 points are in a circle. So the points are lying on the circumference of the circle. So this triangle ABC is inscribed in a circle with AB as the diameter. And AB is 25. So this is 90 degrees here. So what is the area of triangle ABC? So we can solve for AC. So we have already AC. So we have solved AC in our previous slide. So to solve for the area of the triangle, we have many formulas depending on the given. So for this, I have already two sides. I will solve for angle theta. So angle theta by cosine law. By trigo function, I mean, no, pwede lang trigo function because this is 90 degrees, this is right triangle. So, cosine of theta is equal to AC over 25, and theta is 50.19. So, the area of the triangle is 1/2 the product of the two sides times the sine of the included angle. So, 152.93. This is not in degrees, no? Okay, so next we have here. A tangent line is drawn from T to point of tangency at T. A second TB is drawn from T intersecting at point A and B on the circle. So AB is diameter of the circle. Compute the angle PTA. If the angle between the projection of tangent line TP and the line PB is equal to 64 degrees. Okay? So we have here circle, no? Then we have tangent from T, then point of tangency P. Okay? Then a second TB drawn and then intersecting point A and B on the circle. So we have that here. So we have the 2 points A and B. AB as the diameter of the circle. Compute angle PTA, this angle here. If the angle between the projection of the tangent line TP, so the projection of the tangent line TP and the line PB. So I will connect PB by a line. And where is this angle 64? Angle between the projection of TP and the line PB. So this angle is 64. Okay? So compute the angle PTA. This is our unknown here. No? Okay. So have you noticed that this angle 64 is the angle between tangent and a chord? Huh? And this angle between tangent and a chord is this 64. Then we have the intercepted arc. So, considering the intercepted arc, this measures twice of 64 at the center. No? So, this is 128. And if this is 128, this triangle is isosceles. And we have here 180 minus 128. 128 is 52. So, each angle here measures 26. So, 26, 26. Now, at point P, so this angle is 64. So, the remaining angle there is 180 minus 64. So, this is 116. Okay. So, have you noticed that we can now solve for angle theta by using triangle PTB? Huh? So, triangle PTB. So, you have angle 116. You have angle 26. Angle theta is the requirement. So, if you sum up, 116 plus 26 plus theta equal to 180. And theta is equal to 38 degrees. So, we have now the fifth property na. Kasi apat naman yan. Ano ba yun? Recall? Number 1, a line drawn from the center to the point of tangency is perpendicular to the tangent. The angle, number 2, the angle between chord and the tangent. Number 3, inscribed angle. Number 4, inscribed angle in a semicircle is a right angle. Okay, number 5. The products of the segments of two chords are equal. Okay, so if we have here a circle and then we will draw two chords. So let us say chord AB or chord BC. And then we have here another chord DE. Now, so two chords that intersect, they divide themselves into segments. No? So let us say they intersect here and BC has been divided into two parts. I will call it A and B. And DE also divided into two parts. I will call it CD. So number 5 says that the products of the segments of two chords are equal, meaning AB is equal to CD. Then for this, we can also solve for the angle between the two chords. I will call it angle theta. So this is the formula for angle theta. So that is arc CE plus arc BD over 2. But take note, we know already how to measure an arc. An arc is measured as the angle from the center of the circle. So meaning, arc CE here is the measure of the arc or the measure of the angle subtended by arc CE at the center of the circle. So same with BD. Okay, next. We have here, let L1 and L2 be any 2 seconds drawn to a circle. Okay. Circle, then we have second L1. Okay, so let us say second L1 is drawn from A and it intersects the circle at B and C. Okay, then we draw also another second L2 from A then it intersects the circle at D and E so D and E. So anong pwede nating ma-apply? So what are the properties that we need to know? So that is AB times AC is equal to AD times AE. Saan yung AB? That is the external segment of the second L1. Saan yung AC? The total length of the second from A to C. Saan yung AD? The external segment of the second. Then AE is the total length of the segment or the second AE. Then we have here the angle theta. By the way, the angle theta here is the same as this. So we have here 2 chords, so angle theta. So that is arc CE plus arc BD over 2. So arc CE plus arc BD over 2. Then we have also the angle between the 2 seconds, beta. So the angle beta is equal to arc CE minus arc BD over 2. And very important also, take note, these angles here are equal. So I mark it angle P. So if you have 2 seconds, and then you will draw here a chord, another chord drawn here. These 2 angles are equal, angle P. Okay, so we can have a problem. So number 7, we have the chords AB and CD divides the circle into 4 segments. AB is the diameter of the circle, AE equal to 8, CE equal to 12, and DE equal to 20. Compute the area of the smallest segment of the circle if the chords intersect at point E. Okay, drawing na naman. Then, natin So, chords AD and CD divides the circle into 4 segments. So, meaning, my circle, and then we draw 2 chords AB and CD. They intersect, of course. And then, AB, one of the chords, AB is the diameter of the circle. So, the diameter AB and the chord CD intersect, and it divides, or they divide the circle into 4 parts. Question, find the area of the smallest part or the smallest segment. Then we are given here the distances. Okay. So we will draw, para so that we can view the distances. Okay. Circle. I have diameter AB. Unahin ko yan. Then I have chord CD. Then they intersect at E. Okay na? May distances. AE is 8. CE is 12. DE is 20. Question, compute the area of the smallest segment. Itong part na to. Okay, compute the smallest area. Yung naka-green. Paano yan? So, have you noticed that the diameter and the chord intersect and then missing yung distance BE? we can use the product of the chords or product of the segments formed by the two chords. So we have here, so AE times BE equal to CE times DE. So A times BE equal to 12 times 20. And BE is equal to 30. So that is the measure from this point up to this point. So if BE is 38 and AE is 8, so meaning the diameter of the circle is 38. So the diameter of the circle is 38. So meaning we have here OC is 19 because OC is a radius, half of 38. OE is 11. Because this is 19 radius. Then we have here 8. So 11. Okay. So, kita nyo, how will we solve for the area of the smallest segment? So, as what we have seen here, the area of the smallest segment is simply area of the sector COA minus the area of the triangle COE. Sector COA minus triangle area COE. Okay, tingnan natin mga given. So, we will solve for the central angle here. So, I can solve for the central angle by using cosine law. By using cosine law, so we have here. So, using cosine law, I can solve for this angle. I will call it angle theta. So, I have 12 square equal to 19 square plus 11 square minus twice 19 times 11 cosine of theta. So, angle theta is 36.04. Okay. So, we can now solve for the area of the smallest part. Again, area AOC minus area EOC. Or kahit saan maunang letter dyan, area of the sector minus area of the triangle. Now, for the triangle, I have here two sides, 19 and 11. 19 and 11, then sine of the angle theta. Okay, so transfer to the next slide. So, 1/2 19 squared sine 19 squared times angle theta multiply by pi over 180. Minus 1/2 pi 19 sine 36.04. So, this is the smallest area, 52.05. Okay. Number 8. Second AB intersect the circle O at B. Ano na naman to? Second AB intersect circle O at B. While second AC intersect the circle O at E. If AE equal to 4, AC equal to 24, AB equal to 16, find AD. Okay, fine. Okay, fine. Okay. So, may circle O ka. So, may draw muna tayo ng circle O. Ito yung circle O, Then, may second AB. Ito yung second AB. Intersect the circle, Intersect the circle at B. Point dito. We have another second AC. So, we have the same point A here. So, draw na ako ng AC. Intersect the circle at E. E pala to. Ano yung mga distances natin dyan? So, AE is 4. While AC is 24. AB equal to 16. Then, find AB. Madali lang pala. So, madali lang problem na to. Paano to isolve? Simply, we will use the product of the segments. So, that is external times the total equal to external times the total. So, we have here AE times AC equal to AD times AB. Substituting values, 4 times 24. Unknown AD times 16. So, AD is equal to 6. Okay? So, that is about intersecting chords, no? And then we have also 2 seconds drawn to a circle. Okay. Anong kasunod? Tingnan natin. Number 7. Property number 7, ha? Let T1 be a tangent and L1 be a secant drawn to a circle as shown. Okay. So, may circle tayo. Then, tangent T1. Okay. We have also secant L1 drawn to a circle. Okay. So, anong pwede natin ma-apply? Let's say this is C, na? So, A, B, C, D. So, for this, we can apply AB square equal to AC times AD. Okay, kuha, ha? AB square is equal to AC times AD. Then, we have the angle between the tangent and the secant. So, we have here, angle beta is equal to arc BD minus arc BC over 2. Where this is how we measure arc BD, ha? The angle here. This is also how we measure arc BC. So, arc BD minus arc BC over 2. Okay lang? Then we have here, number 8. L1 and L2 be 2 tangents drawn to a circle. So, circle na naman. Then we have tangent L1. We have tangent L2 drawn from the same point. Then we have here, so the angle between the 2 tangents, beta, is equal to this. So, beta is equal to theta minus P over 2. Where this is angle theta. This is angle phi. Okay? Tingnan natin, may problems pa ba? Number 9. Problem 9, ha? A road is tangent to a circular lake. Along the road and 20 kilometers from the point of tangency, okay, ha? A road is tangent to a circular lake. Along the road and 20 kilometers from the point of tangency, another road opens towards the lake. From the intersection of the 2 roads to the periphery or circumference, periphery of the lake, the length of the new road is 18 kilometers. If the new road will be prolonged across the lake, find the length of the bridge to be constructed. Okay, so paano yan? Okay, so we will read again as we construct the figure, ha? Okay, so there is a circular lake, and then we have a road which is tangent to the circular lake. I will call it AB, no? Then, along the road and 20 kilometers from the point of tangency. This is point of tangency, then a distance of 20 kilometers. Let us say here at A, no? Okay. Another road, no? So from the intersection of the 2 roads, no? So another road opens towards the lake. So parang ganito. So from the intersection of the 2 roads to the periphery or the circumference of the lake, the length of the new road is 18. Ayan. So, if the new road will be prolonged across the lake, so the new road will be prolonged to cross the lake. Find the length of the bridge to be constructed. Yeah. Okay. So, ito pala, na? So, bridge to be constructed. Find the length. Okay. So, what have you noticed? The figure forms a tangent and a secant drawn to a circle. Okay, I will call or I will represent the length of the bridge as x. So, anong equation natin dito? 20, 18, and then x. So, we have here, no? From the property. So, AB square equal to AC times AD. So, this is 20 square equal to 18 times 18 plus x. And x there is 4.22 kilometers. Okay? So, we have here. Number 10. We have that. AB is the diameter of a circle having its center at O. Naman, figure na naman, no? AB is the diameter of a circle having its center at O. Madali lang yan. Circle, then AB, diameter, center at O. Points P and Q is on the perimeter. Points P and Q are on the perimeter of the circle. Sige na lang, may mga mali sa mga grammar ng konti. I-correct na lang natin yan, ha? So, points P and Q are on the perimeter of the circle. So, AB, tapos may P and Q. The ratio of arc AP to the arc PQ is 4/3, or 4:3. 4:3. 4/3. Compute the angle AOP if the value of angle PAQ is 24. Okay, tingnan natin, ha? Sige. So, may circle tayo. Then we have diameter AB with center at O. Points P and Q are on the perimeter of the circle. And the ratio of arc AP to arc PQ is 4/3. Meaning, longer AP is longer than PQ because the ratio AP to PQ is 4:3. Compute angle AOP. Saan yung angle AOP? Ito, angle AOP. This angle theta, no? If the value of angle PAQ is 24 degrees. Yan ang given. So, paano mo i-solve yung AOP? So, angle theta. Okay. So, nakita niyo bang nakita ko? So, I have here. So, notice that angle 24, this angle 24 at A is an inscribed angle. No? And the intercepted arc is PQ. Okay? So, this angle 24 is an inscribed angle. And the intercepted arc is PQ. And the measure of PQ is at the center. Itong angle na to. So, if this is 24, meaning this is 48. No? Because the intercepted arc measures twice the inscribed angle. Ayan. Kita na? Okay, now. Diba, arc AP is 4/3 of PQ? Simple. Arc AP over arc PQ is 4/3. But arc PQ is 48. So we can solve for arc AP equal to 64 degrees. So arc AP, or that is angle theta. Okay? So nagkasunod. Here, similar figures. No? We will finish plane geometry today so that we have the solid geometry and the succeeding things. Okay, so similar figures are figures not equal, because equal figures are the same figures. No? So similar figures are of the same shape but not of the same size. So I have here a representative two figures of a rectangle. So I will call the sides here x1 and y1. And we have here x2 and y2. No? Then I have here the diagonal d1 of the first, then diagonal d2 of the second. Let us say perimeter p1 of the first, perimeter p2 of the second, area a1 of the first, area a2 of the second. So yung mga 1 sa first, yung mga 2 sa second. Okay. So if the two are similar, ano yung pwede kong ma-apply? So we have here, the ratio of the corresponding parts are equal. So that means, if we take the ratio x1 over x2, that is equal to the ratio y1 over y2. That is equal to the ratio d1 over d2. And if we have the perimeter, that is, perimeter is still linear unit. No? So that is P1 over P2. So meaning, as long as we have the linear ratio, the corresponding linear ratio are equal. Huh? So x1 over x2. We can say also x1 over y1 equal to x2 over y2. D1 over y1 equal to d2 over y2. As long as we have corresponding na parts. Okay. Ang kasunod, the ratio of their areas is equal to the square of the ratio of the corresponding parts. Okay? So, if we have here area 1 and we have here area 2, so area 1 over area 2 equal to x1 over x2 square. The ratio of the areas is equal to the square of the ratio of the corresponding parts. Equal to y1 over y2 and so on. Okay lang? Sige. So, we will solve problem 1. In two regular polygons having the same number of sides, find the length of the side of the smaller if the lengths of the apothems are 20 and 50, and a side of the larger has a length 32.5. Okay, so regular polygons having the same number of sides. We are not given the number of sides, so we will just assume any number of sides, no? So I will just represent by hexagons, no? So we have here two hexagons, so they are similar, of course, because they are both regular polygons, no? Okay. So we have the smaller, we have the bigger. So the smaller, the question is find the length of the side of the smaller. So I will call it x1. No? Then the length of the side of the larger is x2, and this is given 32.5. Then we have the apothems. The apothem of the first is 20. The apothem of the second is 50. Okay, what is x1? So simply, we can use the proportion. Now, the ratio of the corresponding parts are equal. So, x1 over x2 equal to a1 over a2. So, yung ano natin dyan, yung x1 lang, no? So, x1 is 13. Okay? So, that is similar figures, no? Problem 2. The scale of a map is 1 is to 2,500. So the scale of the map is 1 is to 2,500. A circular sports field has a diameter of 8 cm on the map. Calculate its area in hectares. Okay. So if you have a scale on the map, so that is a ratio 1 in the actual corresponding to 2,500. 1 in the map, I mean, mali. The scale means 1 is to 2,500. That is 1 in the map corresponding to 2,500 in the actual. Okay. Then we have a circular sports field that has a diameter of 8 cm on the map. What is its actual area in hectares? Okay. So we can have the proportion. The area in the map is to the actual area. So that is equal to the scale square. Because when you have the scale, that is ratio of the corresponding parts. Ratio of the corresponding parts of the map is to actual. So this is linear proportion. Okay? So we can have the ratio of the area, map is to actual, and then we have the ratio of the corresponding parts, the scale, we square it. Okay. We can solve for the area in the map because we are given the diameter, that is 8 cm. I will convert 8 cm into meter, 0.08. Then 1 is to 2,500 square. So I can solve for the actual area in square meters. But I will convert it into hectares. So 1 hectare is 10,000 square meters. So we can solve for the answer 3.14 hectares. Okay na? So similar na. Okay, number 3. Last problem na. The lengths of the sides of a triangle are 6, 8, and 12. If the length of the shortest side of a similar triangle is 10, what is the length of its longest side? Parehas lang. Similar, no? Okay. So, smaller one, we have x1 equal to 6, x2 equal to 8, then x3, the longest, is 12. Then I have the second, no? The shortest side corresponding to x1, so y1 equal to 10, y2, and then y3. What is the longest side? Okay, the question there is y3. So simple, no? Proportion corresponding parts. So I will just use x1 over x3 because parang nagkamali to. Interchange lang, no? Sandali, parang may mali. Nako, nagkamali. Last na, namali pa. Nagmamadali na siguro. Okay, interchange na lang, ha? This is y3, this is y2, ha? Okay, note, no? Sige. So, this is y1, y3, y2. X1, x3, x2. Longest man, no? Okay? So, we can have x1 over y1 equal to x3 over y3. Can we change this to y3? Change this to y2. So, we have y3 equal to 20. Okay, so that ends our discussion. So we have finished plane geometry today, no? So next meeting, we will be discussing solid geometry. Solid figures, then their properties, the computation of the volume and the surface area. No? Okay, so thank you for listening. Thank you for viewing my video. And I hope we're in good health. No? Stay safe, everyone. God bless.